Uh, Today we'll be starting discussing about these topics, guys. So today's agenda is to discuss about 8 puzzle problem using heuristic search method. So previously I have explained you about what is the heuristic search method, and as part of that we also have discussed about different types of heuristic search techniques. Today we'll be seeing an example of how we will be solving 8 puzzle problem using heuristic search method. So the same problem can be solved using n number of ways. The 8 puzzle problem, the 9 grid what I have shown in the previous sessions, that can be solved using both approaches, heuristic and non-heuristic approaches. So today I'll be explaining you about how this puzzle can be solved using heuristic and non-heuristic approaches, and also upon completion of that we'll be discussing about one important heuristic approach called as hill climbing algorithm or hill climbing approach, and also different types of hill climbing approaches. So after that we'll be discussing about iterative deepening search, and probably we also will be talking about one more algorithm called as A star search algorithm, which is very important technique as part of your heuristic search methods. So coming to your syllabus, guys, this
Sir, your screen is not clear, sir.
is very important.
Now it's okay.
What happened? Discussions, some small disturbance here. Okay, moving on, guys. Let's discuss about this problem. So this problem is very important. So in examinations point of view, heuristic search methods is very important for you, because you'll be having a lot of problem solving methods as part of your heuristic search methods. Also, when we have discussed about exhaustive search methods, there we have seen about breadth first search and depth first search algorithms. And also in the previous session I have discussed about what are the different types of heuristic search methods. I can show you on the screen what we have discussed in the previous session. This is what we have discussed. What is a heuristic search method, how it will be traversing, and what is a heuristic function, how that value can be taken. Somebody asked me in the previous session how can that value be taken. So today we'll be discussing about that part also. So what are different types? As asked in the poll previously, you all gave me the wrong answer. Many of you gave me the wrong answer. The different types of heuristic search methods are admissible and non-admissible. So people who have gave wrong answer, please correct that. Yeah. So today we'll be discussing about this concept. So how this 8 puzzle problem can be solved using heuristic search method. Okay. Everybody who is watching the screen, please look at the screen properly. Here you can see a small box, a grid-like structure, a start state and a goal state. This are already this topic has been discussed, but now we'll be talking it in terms of your heuristic search method. Okay, so we'll be talking about we'll be taking an 8 puzzle problem where we have a start state and a goal state. So in start state and goal state, the common thing what you can see is a grid and there are some numbers. But in the start state, the numbers are arranged in different manner, and the goal state, the numbers are in different arrangement. The arrangement is different. So the agenda here is we need to get the goal state also similar to your start state. That is the game what we are going to play now. So our task is to slide the tiles. So tile here is the grid box or the empty one what you can see, that is called as a tile. So we need to start from some current start state and we need to reach the goal state. So whatever you are having in the goal state, that is the structure we need to get. So in start state you are having numbers in different manners. So now we need to get them sequentially. So here in the image, the goal state is given in this manner, like starting from 1 to the right, again down, left, and again top, in this manner. So the goal state can be varied every time. So even as part of your questionnaire, it can be problem solving questionnaire, or it can be a university examination, anything. The goal state will be given to you and the start state will be given, and you will be asked to follow any approach, like it can be heuristic technique directly, or they may specify that it should be a greedy approach, or they may specify it should be a breadth first search approach. So they will be specifying the different types of approaches, and according to that we need to follow the steps sequentially and complete the problem. So in today's example, I'll be explaining a step-by-step procedure how this can be considered, and also as part of this I will make you understand what is a heuristic function value and how that can be computed. Okay, so our task here is you need to move the slide from current state and reach the goal state. In order to reach the goal state you need to move the slides in different directions. So here there are four probabilities for you, or four chances, like you can move the slide down, up, right, or left. So you can move it in any of the direction and finally reach the goal state. That is what we will be discussing today. There can be several ways this can be solved, but in today's example we will try to compute a heuristic function value and solve this problem. Okay, yeah. So to effectively compute this problem, what should be done? So initially, if I want to use heuristic search methods, I need to compute the value of h of n. So h of n in this problem is number of tiles out of position. So this is very important understanding, guys. In the start state and goal state, we need to compare the arrangement of the numbers in the grid, and we need to see how many tiles or how many numbers are not arranged properly as per the goal state. So if you can observe the first row in both the states, that is you're having the value 1, 2, 3 in the start state and also 1, 2, 3 in the goal state. So you can very clearly say that both these are following the same structure and there is no problem in arrangement. And coming to your second row, in second row you are having number 8 in both the 8 in the same place in the both the grids. But coming to your number 6 in the start state and comparing it with the goal state, in goal state it is empty and in start state it is 6. So we need to arrange this because it is not following the structure of your goal state. So this is not as per your proper position. And also you can see 4, again 6 and 4 are not arranged properly, and 7 is again arranged properly. So 5 is not in the exact position. So like this we need to check and we need to say how many tiles are not following the proper position or proper structure. So here comparing these two grids or these two puzzle problems, there is total of 3 tiles out of position. The 3 tiles are 6, 5 and 4. These 3 numbers are not arranged properly. So our goal here is we need to apply any move. It can be right, left or any move, and we need to understand these 3 numbers should be arranged properly, then only the goal state will be reached. So because the count here is 3, that's why I'll be saying that h of n is equal to 3. So assume that the one number, the count number 1 is not in the same state what is shown here. So assume that in place of 4 in the start state there is number 1, then you will be having h of n is equal to 4 because 4 numbers are not arranged properly. So we need to first understand the problem here is how many tiles are not in the proper position. That will be your h of n value. So this should be very clear, guys. If you are clear with this point, we can move forward. Okay, so how to compute the value of h of n, that is heuristic function. So according to your 8 puzzle problem, we can say that how many numbers are not arranged properly as per the goal state. It can be termed as your heuristic function value here. So from this grid we can say h of n is equal to 3. So now we have understood what is your h of n and how to take that value, but what is our goal now? So we need to minimize the value of h of n is equal to 3 to h of n is equal to 0. That is, if you want to make your start state and goal state equal, the arrangement should be done in such a way that both are equal. Then the h of n value will be equal to 0. That is what is our computation now. And now let's look at how this can be done with respect to your heuristic function. Yeah, so you can see here, guys, the solution for the problem what we are discussing now. Yeah, so here you can see I'm considering the start state grid and I want to reach the goal state grid. So I have taken the start state grid here. You can observe very clearly 1, 2, 3 are need not to be disturbed, and 8 need not to be disturbed, and 7 need not to be disturbed. So we need to only arrange 6, 5 and 4 such that we will be reaching the goal state. And for that I can apply any of the probabilities, that is the 4 chances. You can move right, you can move down, you can move left, you can move up. So as per our requirement, we will apply the moves. So here you can see in the first step, if I want to arrange these three numbers, as I said, h of n value is equal to 3. So you are having three chances here. That's what is the discussion. So from the first step to the second step, you are having three probabilities can be done. That is, initially I can move number 6 to the right place, or I can move 4 to the upward direction, or I can move 3 to the downward direction. All these three probabilities can be computed. So I hope everybody is following the session, guys. Any doubts? You can just keep me a message. Any sort of confusions? Is the problem understood everybody, for everybody? Because depending on this problem, I would like you to give some assignments, how to compute the value of start state and goal state using different approaches. So it can be any heuristic function. The procedure might be different, but the problem understanding is same. Okay, because we are having the value of h of n is equal to 3, I have taken three moves here. So you can see here again, I can say 1, 2, 3, 8, 7 are arranged. So going to again previous slide, you can see if I want to reach goal state, I need to have 1, 2, 3, 8, 4, 7, 6, 5 as my structure. So that is something equal to my second position. Why? Because here the numbers are arranged again in the different structure, and you can see again compute the h of n value. So for every solution, you need to compute the value of h of n, and the step 3, you can see that the right side node is giving the h of n value as 3 again. So that is what is given, and h of n value for the upper node is 2, and for the down node h of n is equal to 3. So if you want to move forward, you need to take the value which is having h of n value as less. So as I said in the initial conditions, if I need to compute h of n value is equal to 3, and I need to reach to h of n is equal to 0, which means I am decreasing my h of n value. So now I will be taking h of n is equal to 2, because if I see at the start state and goal state, 4 is arranged properly. Now I need to arrange only two numbers, that is 6 and 5, which are not according to my goal state. So now again I'll apply, I'm having two probabilities here. I can move right, I can move down. So because depending on the probabilities what you're having, you need to move. Okay, so now I have applied my right condition, which means I have moved 5 to a right direction, and also after that I have moved my 4 to the down direction. So again you can see the down direction is again misleading us. H of n value is again 3, and in the right side condition, what I have when I applied it, 5 has been moved to the right place. You can see the goal state, guys. You need to have 5 at the corner, and I'm having 5 at my corner, and also 4 is arranged properly according to my goal state. So this is again done. So if I again compute the h of n values, the right side grid is giving me h of n value as 1, which you can see here. The pointer is pointing over there. H of n is equal to 1, and h of n is equal to 3. So obviously I need to take the value which is h of n is the lesser value. So because h of n is equal to 1, if I move only one value down, my goal state will be reached. But again here I am having two probabilities. I can move my 6 number downwards, or I can again shift my number in the different direction. Okay. So finally you can see the goal state is being reached here, and this is how we need to traverse. So as a human being, we can easily say that this is very simple process. Why we are stressing over here? But assume it as part of your intelligent agent, or as part of your machine learning algorithm, which you are training a robot or any other machine. So you need to have a solution according to your machine. That is the condition for us. Okay, so finally we have reached the value of h of n is equal to 0. That is, goal state is achieved. From h of n is equal to 3, I have applied till h of n is equal to 0. So I have taken a small example here, guys. Like I'm already having 1, 2, 3 as the arranged properly. But sometimes you may be having some h of n value as 5. H of n value can be 6. That is, 6 numbers can be jumbled. So at that time, you will be having some different steps. You'll be having some more number of computations, and the tree may be increasing, and finally you will be reaching your goal state. So this is how we traverse with respect to your heuristic approach, how we can move forward. So if I don't follow a heuristic approach, still this solution can be done. It can be done your breadth first search algorithm. So that is, every time it will be traveling from left to all the different states, and finally it will reach the goal state. But what is the difference and what is the advantage of applying heuristic search method in place of exhaustive search? Why should I prefer a heuristic search? So that means, because you are computing h of n value every time, the values which are having h of n value more than the suppose you can see in the depth one place here, you are having three values: h of n is equal to 3, h of n is equal to 2, h of n is equal to 3 again. So I am considering only the particular node or state which is having less h of n value. But compared to your BFS algorithm, if you are applying a breadth first search algorithm, you will not ignore any state. You will be also computing h of n is equal to 3 value. So as part of your BFS, you will be taking all the nodes into consideration. That is why it will take a lot of time to get to some solutions. So if you are using heuristic functions, definitely the time complexity will be reducing, and you will be getting with a solution with respect to your cost. The cost of the solution also will be less. That's why heuristic functions are much preferred compared to your exhaustive searches. Okay, yeah. So from the above diagram or tree, you can see that the value has been decreased from h of n is equal to 3 to h of n is equal to 0. Okay, but however, we can create and use several heuristic functions. So as I said, you'll be having different approaches. Like you'll be having iterative deep learning approach, best first search. We can also call it as best first search or greedy approach. Any approach can be applied, and finally the solution can be obtained. This is what is the understanding about your heuristic search method. Okay, I guess now everybody at least got some understanding about what is your heuristic search method, how this is being followed. Now we'll be discussing about one more approach called as hill climbing algorithm, which is very important heuristic technique. So in real, this can be mapped to your real life problem. How when you're climbing a hill, you'll be having lot of peak positions, some what do you call, some plateaus, some slanting positions. There will be different types of things, and if you want to reach from bottom to top while climbing your hill, what are the different problems you'll be facing. And we are not talking it in generally, guys. You also will be playing many games, car games, which are having a lot of steeps, ridges, and you'll be trying to climb a hill. So the same concept is being discussed here. So if you want to develop any game of such type of strategy, the hill climbing game, which kids will be playing basically as part of their games. So if you want to develop such type of algorithm, you need to understand what is the technique we are going to follow as part of your development. So you are going to apply your heuristic search technique, where the person who is climbing up on the hill estimates the direction which will lead him to the highest peak. So starting from the bottom to reach the highest peak, he need to follow n number of strategies. The person whoever is going to climb the hill, he need to check whether if I go in this direction, do I need to face any difficulty, or do I need to apply more energy, or instead of that, if I want to save my energy, in which path should I go? So he should have some estimation in which direction he need to go. That's what is we call it as hill climbing algorithm. And the purpose of this hill climbing search is to climb a hill and reach the topmost peak of a hill. So starting from the initial stage, and to reach the topmost stage, you will be having lot of hurdles, and you need to cross every level properly, and then only you can reach to the topmost position. Let's understand about this in detail. What actually is this hill climbing algorithm? So the state space landscape of hill climbing algorithm is here. In the graph you can see some different terminology here, like there's a shoulder, which is like the shoulder, you'll be having some slanting and a graph again. And also you can see the highest peak, it is mentioned here as global maximum. The global maximum, it is the highest point on the hill, which is called as the goal state here. So starting from a minimum state, you need to reach to the goal state. So next one is local maximum. This is one again important thing. The local maximum is the next highest peak after your global maximum. The second highest peak is called as your local maximum. And next one is flat local maximum. It is the flat area over the hill where it has no uphills or downhills. We call it as a flat surface, and it is the local maximum. Okay. And next one is, as I said, you will be having a shoulder, and you can see in the graph a current state. So current state indicates where and which direction you are moving in. So this is a one-dimensional states representation of hill climbing using your objective function. So here again the goal is same. You need to reach from the current state to the goal state. So moving in your direction. So you can be, it can be different hurdles you can get. So I'll be showing you in the next slide what are the different types of hill climbing approaches. So I guess everybody need to understand the terminology here. What is global maximum? What is local maximum? So what is a shoulder here? So what is a flat local maximum? What is the objective function? So this is a thing what we'll be discussing about as part of your hill climbing algorithm. And keep one thing in mind, guys. While we are discussing about this many types of algorithms, so I'm not going to say that as part of unit 1 you need to write algorithms for everything. It's like you need to have an understanding of what are the general problem strategies. So as part of your general problem strategies, what are different search methods adopted as part of your development. So we are going to just have an overview of all these things. So I may not talk about the implementation of these algorithms using your Python or any other programming languages, because we are not having a lab as part of our understanding. So we need to theoretically understand what are the different techniques we need to learn if you want to implement AI in your further years. So as I already mentioned in the initial sessions, you will be in a position to reach understanding a problem if you are knowing all these things. In the higher levels, whenever you are having a problem solving problem, it can be a project. So at that time you will be having an understanding like which approach can be applied. So according that you will be writing your program, you'll be doing your implementation, then we will be looking for the next sessions. So as of this subject, whatever you are discussing as part of this current academic year, so you'll be having an overview of every different techniques what they have developed as part of your AI. So don't be like we are just discussing about only some theoretical aspect of your algorithm, because that is the limitation according to our syllabus. So if you want to reach the next level of this understanding of your algorithms as part of your examples, you need to even explore. Then only you'll be understanding a lot of examples. So we are just trying to showcase only one or two problems as per the limitations of number of classes we are having. But apart from these sessions, you can explore a lot and try to understand these algorithms in detail. So now, as I'm saying that what is a hill climbing approach, so you need to understand the real world problem, like take a problem as 8 puzzle problem, then try to apply this algorithm with respect to an example and understand the solution. But as part of our sessions, we are just having an overview of what are these algorithms and how we can explore these algorithms for which type of problems. Okay. Again, talking about these types of hill climbing algorithms, there are 4 different types. As part of our syllabus, we discuss about simple hill climbing algorithm. But apart from this, we are having 3 more algorithms called as steepest, ascent, hill climbing. So whenever you are having a steep type of things, how to go your approach. Next one is stochastic, which is very the meaning only. The stochastic means something like it is a complex one, and the random restart hill climbing. That is the wherever you are going to stop, again they'll be starting from the random place, and you'll be getting your solution. So you need to keep these 4 that you need to have understanding about these 4 types of algorithms. But as part of your examinations, we may ask you only about your simple hill climbing algorithm. Okay, don't need not to worry about you're having a lot of stuff over here. So So it's your understand. I'm just trying to make you understand what is that actually you need to learn as part of your AI. Okay, now let's discuss about these algorithms in detail. So coming to your simple hill climbing approach, it is the simplest among all the four approaches. If you want to adopt your hill climbing approach, the task is very simple. You want to reach to the highest peak of the mountain according to the steps what you want to go through. So here the movement of the climber depends on his moves. So according to his understanding or his estimation, he will try to apply moves. So whenever he's moving forward, if he gets the goal state, if he reaches the maximum state, he will try to stop, or else he will try to move forward until he reaches the goal state. Okay, the focus here is from moving from previous. So you need to understand what is the previous step and what is the next step. Then only the solution can be obtained. So now let's see the algorithm about what this is. In simple, it is only a 4-step algorithm for your understanding. So you'll be creating a current node or a current position of the hill climber, and you'll next understand what is the neighbor node, or next what is the goal node. Do I need to go to the goal node? If I want to go to the goal node, I need to move from current node to the neighbor node. So the second condition, step 2 here is, if the current node is equal to goal node, so that is goal is reached, and we will stop the process. So sometimes you can directly reach to the goal state very easily, but basically in terms of your hill climbing, it's not so easy. You need to apply lot of you need to follow a lot of movements. And step 3, if you are not having the final goal node, so you need to compare with the neighbor node. So if you are having the neighbor node, you will move ahead and try to go to the goal node. So until that, it will try to loop, and whenever you're getting a goal node, it will be stopping the algorithm. So this is what is the simple approach of your hill climbing. So as part of your examinations, this can be asked, guys. So you need to understand this basic terminology of simple hill climbing. What is the task here? How the task has been approached, and what is the small algorithm what we are discussing now. And next one is steepest ascent hill climbing. So here the thing is same. There is some small difference as part of your simple hill climbing. So unlike that, here it considers all the successive nodes, compares them, and whichever the node is the closest to solution. Suppose assume that I am at a position and I am having some 3 different paths, and I'll be comparing 3 different paths, and I'll be selecting if I go to which node, like what we have seen previously in your Delhi and Jaipur algorithm. So you can see here, guys, in the previous session we have discussed about this. If I want to move from Delhi to Jaipur, so I'll be looking into all the probabilities, and whichever the solution, whichever the value I'm getting lesser value, the heuristic function value here is h is equal to 270. Then I have moved from R2 to Jaipur. In the same manner, here in the steepest hill climbing algorithm, it will try to see go through all the different phases, and whichever the path is giving the quick solution, that will be selected. That is what is about your steepest ascent hill climbing algorithm. So it is similar to your best first search. The best first search algorithm is yet to be explained. The next concept, whatever you are discussing, is about your best first search algorithm. So there again, I'll show you an example how this can be done. Okay, and compared to both steepest and simple algorithm, both fails when there is a no closer node. If there is no node closer to that, both of these algorithms will be failed, and we need to move for the other 2 algorithms. So this is the algorithm for your steepest ascent hill climbing, guys. So here you are having some 5 sort of steps. So other 2 approaches of your hill climbing is stochastic hill climbing. As I said, it does not focus on all the nodes. It only randomly selects some nodes and move to that solution. So here solution cannot be expected 100% because it is randomly selecting a solution, and the path may lead to solution or may not lead to solution. So according to the moves, whatever you're selecting randomly, that only will be your path. And coming to a random restart hill climbing, so it is like try and try strategy until you get your destination. So iteratively searches the nodes and selects the best one until the goal is not found. So until the goal is reached, it will try to search the best path, and will try to go in that path. Okay, success depends on the shape of the hill. So sometimes I can say the shape of the hill is okay, you may reach a destination. If there are more ridges or more what do you call steeps, then there is the destination may be a problematic one. So as part of your hill climbing, you need to keep these four types of hill climbing algorithms in your mind, and for your examination you need to concentrate on this one, guys. Okay. Yeah, so once this is completed, we are done with hill climbing concept, and we will move for your iterative deepening search. That's what we call it. We call it as best first search. The best first search or iterative deepening search, it is the combination of both breadth first search and depth first search. So when you're talking about BFS algorithm, breadth first search, it will traverse from one state to every state in a zigzag direction. That means it will be trying to cover all the depth, and it will try to provide some solution. And coming to your DFS, depth first search, it will try to pass only in one direction where solution is being obtained. That's why this algorithm called as best first search or iterative deepening search, which is a combination of both BFS and DFS. It will try to reach the goal node, and it occupies less memory by using your DFS. So it can definitely guarantee a solution because it follows a BFS approach, and it will try to reduce the memory space because it follows DFS algorithm. So the first point here is very important, guys. In the screen, you can see the first point. So whenever a question is being asked about your best first search or iterative deepening search, you need to write this point very clearly. It is a combination of BFS and DFS, and it uses BFS and try to guarantee a solution, and it uses DFS to reduce the memory space. That is what is the understanding from this concept. Okay. So gradually I can see you a small picture that understanding here. So if I take this example, initially you are having 0, 1, 2, 3 are the depth. So I can, starting from A, if I want to reach H, so I need to follow both BFS and DFS, and I need to get some solution. Okay. So yeah, so therefore it gradually decreases from depth from 0, 1, 2, and you can see here 0, 1, 2, 3. Starting from 0 state, 0 depth, you need to reach to the 3 depth. So in the figure, the goal node is H, and initially the depth is, you need to move from 0 to 1, and you can see you are having a condition like, as I said, you will be traversing the path from 0 to 1 in terms of A, B and C. So because it follows BFS, it is traversing from A to B and B to C. If it is a DFS, it need not to go for C. So initially it is following a BFS approach here, and next moving on, it will try to apply DFS, depth first search, and finally it will reach the position that is H. This is what is about your iterative deepening search. And as I said, the algorithm is again very simple here. Yeah, so it will try to explore the nodes in DFS order. So initially we will try to come from A to B, and it will search for the solution. If not, it will go for C. Set a limit variable within a limit value. So because it is also heuristic search technique, it need to compute the value of H of n, and it will try to loop each node until the limit value, that is the goal value, is reached. And further, if goal value is not reached, it will try to increase the value, and it will stop when the goal state is found. So here you can see, if you want to reach from A to H, it is following a sequence of depth from 0 to 3, in the sequence A, B, D, F, E, H. That is the order it is following. So we'll try to look at about this in the upcoming sessions with a different example. So as of today's session, try to understand what is the iterative deepening search and what is its overview. So how this algorithm is being applied as a combination of BFS and DFS. So these are the performance measures of your iterative deepening search. So it will be having a completeness because definitely a goal will be reached. Sometimes it may not also reach the goal if there is a larger one. So it is only preferred for your smaller type of your trees. The space complexity is similar to your BFS, that is big O of B of D. Here B indicates branches and D indicates depth. That is what is the indication of big O of B power D or B of D. B means branches and D means depth. So I can say if branches are 3 and depth is 10, it is 3 power 10. That is the complexity. And time complexity is big O of D. Okay. So the drawbacks of this algorithm is here it is the search is that it is one second guys. Okay, so yeah, the problem here is iterative search is that it seems wasteful because it generates states multiple times. Yeah, so while we are traversing the iterative search algorithm, it will try to generate lot of state spaces and it will try to consume lot of time. That's why that is the only drawback which is happening. It is happening, which is having, and it. One second. Yeah, so it is this requires lot of a large space and the depth of solution is unknown. Sometimes if you are having a large type of tree or large solution is required, so this again fails to give, it will try to take lot of space and depth of the solution is unknown. That's why sometimes this is not preferred, and at that time we go for a different approach called as A star approach, which we'll be discussing in the next sessions. In tomorrow's session we'll try to discuss about greedy approach and A star algorithm as part of your heuristic search technique. So guys, okay, one second. So the I think the